Okay, let's look at this particular example and evaluating limits of sequences. So here it is a weird example. So what we know is the limit as n approaches infinity of 1 plus 1 over n power n. But here this one has changed to positive. So now what do? We need to find a way of evaluating this. So here as usual, we are going to do a transformation on this particular thing. So as usual, we have the limit as n approaches infinity of 1 minus 1 over n power n. So I will say let y to be equals to 1 over n. Now as n approaches infinity, y will go to 0, because as this n becomes big and big, this value becomes 0. Okay, so right now, and from here to this will imply that n is equals to 1 over y, like this. So we come back and rewrite this limit. So we have the limit as n approaches infinity of 1 minus 1 over n power n. This is equivalent to the limit as y goes to 0 of 1 minus y all power 1 over y, like this. But we want the value of this particular limit. So we don't know what the value is. So we can say that let the limit as y goes to 0 of 1 minus y power 1 over y equals to L. So here we are going to take log of both sides. So I'm going to take log. So ln of the limit as y goes to 0, 1 minus y all power y equals to ln L. But here I can write this as the limit as y goes to 0 of ln 1 minus y all power 1 over y equals to ln L, like this. But as the laws of logarithm, you know that I can write this as the limit as y goes to 0 of 1 over y, because this power here can come down, ln 1 minus y equals to ln L, like this. But here we can actually have the limit as y goes to 0 of ln 1 minus y all over y. This y is multiplied, so it can come down here, equals to ln L, like this. So if we take the limit as y goes to 0, what will happen? You realize that I will have ln 1 over 0, which is equals to 0 over 0, that's equals to ln L. And this is indeterminate. Indeterminate. We cannot determine it. Okay. So now what do? We need to. Oh, sorry, I'm coming. I think I've lost page. Okay, so let's continue. Let's continue. So we got 0 over 0, which was indeterminate here. So now what do? So we need to differentiate the down and differentiate the top and take the limit again. So we take limit, sorry. So we take limit as y goes to 0. So we now differentiate. So d dy 1 minus this ln y all over d dy of y. Let's see, it's equals to ln L. So we now have limit as y goes to 0, 1 over 1 minus y times the function itself, which is negative 1. We're differentiating the y here. The negative y is negative 1. All over differential of y with respect to y is 1 equals to ln L, like this. And so we have the limit as y goes to 0, negative 1 over 1 minus y all over 1 equals to ln L. Now we take the limit as y goes to 0. So this will imply that I have negative 1 over 1 minus 0 all over 1 equals to ln L. And so get negative 1 over 1 all over 1 is equals to ln L. And this negative 1 equals to ln L. So right now, what do we do to get the L, which is we assume to be the limit? Now take e of both sides. This and this will go. So therefore, our L is equals to e power negative 1 is equals to 1 over e as our final answer. Thank you for watching. Kindly subscribe.